Hello and welcome to Math World. Today we're going to talk about solving systems of inequalities. So that word system just means that we're going to have more than one inequality. So inequality means it has the inequality sign instead of an equation. So here we go. We have two inequalities. Y is greater than 2x plus 3 and y is less than or equal to negative 3x minus 4. So the solution to this system would be an ordered pair, an xy ordered pair that is true for both the top and bottom inequality. Now, instead of sitting here and plugging in x and y values and trying to figure it out, we are going to graph both these inequalities and use the graphing method to solve this system of inequalities. So let's go ahead and begin. The first thing we want to do is graph each inequality. Remember, we can graph inequalities the same way we graph equations. So for this first one, which I'm going to be doing in blue, I'm going to start with a y-intercept of 3, so up 1, 2, 3 on the y-axis, and I'll use my slope of 2, up 2 over 1. So using your y-intercept and slope, we can also go down 2, back 1, we can get the line for this inequality. Now, what's different about inequalities than equations is the inequality sign isn't always going to be a solid line, because this one says y is greater than, not or equal to. It will actually receive a dashed line instead of a solid line, meaning that this line is going to be more of a boundary line than an actual line that includes the solutions. It's a boundary line. And then for inequalities, we're going to have to shade this graph. Remember, this is not actually the line itself is not actually the solutions. Our solutions are going to be some number either above or below this line. And the way we do that is we test a ordered pair. The easiest ordered pair to test is 0, 0. So let's see, is 0, 0 a solution to this first inequality? Well, let's plug in y of 0 and x of 0, 2 times 0, and see, is that true or not? Well, let's see. Is 0 greater than 2 times 0 is 0, plus 3 is 3. Is 0 greater than 3? No, 0 is not greater than 3, which means this little ordered pair down here is not a solution. We cannot shade 0, 0. We're going to need to shade on the other side of the boundary line. So shade everything on this side of the boundary line because, well, we can't shade the right side because 0, 0 was not a true statement for that inequality. So there's our first kind of thing we need to do, which is simply just graph an inequality. And we learned this earlier in the year when we were graphing one inequality at a time. And there we go. We now have a nice, pretty solution set to the first inequality. But this is systems of inequalities, and systems means we're going to have more than one. I like to use yellow because, well, you'll see we get to combine two colors. And what does yellow and blue make? Well, it makes my favorite color. So we're going to use yellow for the second inequality. We'll have a negative 4 as our y-intercept. So let's go down 1, 2, 3, 4. And we have a slope of negative 3. So we'll go down 3 over 1, down 3 over 1. Or going backwards, we can go up 3 over 1, up 3, back 1. One more, 1, 2, 3, back 1. And then we look at the inequality sign. It does have an or equal to symbol on it, which means we do get to have a solid line this time instead of a dashed line. And if you're doing this on paper, you want to use a ruler, of course. There's my line, but now we need to shade. So we're again going to test 0, 0 for the yellow line. Should I shade the right side or the right side or the left side for the yellow line? Let's see. Is 0, 0 a solution? We're going to plug in, is 0 less than or equal to negative 3 times 0 minus 4? Is 0 less than or equal to that? Let's see, that makes negative 4, sorry. So is 0 less than negative 4? No, no, it's not. Which means this is, again, not a solution. Again, 0, 0 is not a solution because it wasn't true. So we have to shade everything on the other side of the boundary line. We're going to shade over here. So I cannot shade my 0, 0. You got to shade on the other side. Notice that I'm ignoring the blue line. I'm just following along the yellow line this time because I'm trying to graph the yellow inequality as if nothing else was there. Now, what happens when you graph two inequalities on the same graph, check this out, is that you end up with one section, this one little triangle that's only yellow, but then another triangle, or whatever shape this is, that is double shaded. It was already blue, and now I'm shading it yellow. And what does blue and yellow make? Well, it makes my favorite color, green. And I like to use green to represent the solution set. So we now have a little triangle up here that's only the solutions to the first inequality, and a little triangle down here that's yellow that's only solutions to the second inequality. And this green region is our solution set, our solution region for both inequalities together. That means that any ordered pair, such as -8 and +7, this ordered pair right here, -8 and +7, that would be a solution. You could plug those x and y values into both inequalities and it will make a true statement. And of course, there's a lot of inequalities that will fit in this solution set, such as, let's see, -5 and 0 is one. Even one off the graph way out here, like maybe -20, would probably still be in this green region. So there's lots of solutions. In fact, there's an infinite amount of solutions because this graph does continue infinitely to the left. And then what do you think this non-shade region out here represents? Well, this is kind of like the no man's land where no ordered pair in here would be a solution for either inequality. This is definitely don't choose anything out here. We're looking for this double shade region. All right, so that is the short of how to solve a system of inequalities. I do also like using Desmos calculator. I'm going to go ahead and pull up my Desmos calculator here because, if you know how to graph an inequality, well, then you really don't need to do it by hand. You understand how it works. So instead, what we'll do is we'll use the Desmos graphing calculator to graph both of these. So our first one was y is, and I'm going to use the little keyboard down here, y is greater than, it was 2x plus 3. Look, there's my first one, and they're using red instead of blue. I can actually change this color, I think. Hey, look, there's blue now. And then their second inequality, let's see, was y is less than or equal to -3x minus 4. I don't want it to be blue again. I mean, that's kind of boring. Let's make this one. I lost my color. Come back. I want it to be. There's no yellow. Come on. How am I supposed to make green? All right. We'll go red for this second one. And let's take a look at it. Oh, look, it looks just like the one I had done. You can change the zoom a little bit, but here we go. We can see this blue region for the first inequality and now a red instead of yellow triangle for the second inequality. But this double shade region that used to be green and is now purple, I guess, is the solution set. And as I zoom out, you can see that solution set's actually really large. Remember I said there's an infinite number of solutions out here. So the Desmos calculator is a really nice way to find your inequalities. The only other thing that's a little tricky is that the line's solid, it actually includes the solution set. So any point on this line, these are all solutions. Whereas a dashed line down here is not a solution set because it cannot be equal to that line. So these would not be solutions. They're close, but not close enough. And that's pretty much it. All right, well, that's solving systems of inequalities, and I'll see you in class.